All right, everybody. Today we are going to be talking about cubic functions. And so here we have notes 3.8 right in front of us. Today we're going to be describing the transformation of cubic functions. And of course, we are going to graph cubic functions. So we're going to be doing two things. Now, a cubic function. First of all, when you're working with a cubic function, it says a function that can be written in this form. F of x is equal to a, x minus h to the power of 3 plus k. There's that classic HK concept we've talked about before. But of course, that's the reason right there, that highlighted number 3, or power of 3 to be exact. That's the reason we call something a cubic function. To be a cubic function, our degree or our greatest power that we get is 3. And so that's why we see it right here. Now, of course, we've already talked about A, we've talked about H, we talked about K in the past. Well, guess what? Here it is again. So when we're looking at a cubic graph, a curve-shaped graph that is formed from a cubic function. All right, well, it doesn't tell us too much, but I do want to mention, and so here we're going to draw a little graph for ourselves. A cubic graph looking like this. We have this graph right here. So give yourself a quick little XY plane. Doesn't take long to do. This is the most basic of all cubic function. Y is equal to x to the power of 3. This is what we call the parent function. And when we're talking about the parent function, it goes through 1, 1. Here we go. 0, 0. And negative 1, negative 1. Now, when you look at it like this, it looks like it might be linear. But we have seen it in the class before. It has shown up in a few assignments. Think of it this way, and this is the easiest way to draw it. Think about drawing half a parabola going up, and then think about drawing half a parabola heading down. This is what we call a cubic function. And this is the most basic of all. So we're always going to be looking for these three. And we have a vocab word coming up shortly that we'll mention here. Actually, let's do it now. It does say that when you have something called an inflection point, it's kind of what we call the vertex. It's just normally a vertex is, we call it a turning point. A vertex is usually for parabolas and other curves like it, but it is a point of the curve at which a change in the direction of curvature occurs. So a change of direction in curvature. Well, that means this point right here. This would be our point of inflection. This one right here. Notice how it was basically half a parabola heading down, but then it curves. Instead of coming back down again, it curves and starts to go up. So there's a change in curvature that happens there. And then, of course, just like everything else we've done in the past, we do have numbers in different spots. So for instance, we have the A value. When we have the A value, A indicates a reflection in the x-axis and or a vertical stretch or a vertical shrink. So we can have this, or we can have a reflection on the x-axis. So remember, if my A value is negative, so if A is negative, then we're being told to flip, right? Flip it on the x-axis. Well, we've done that before. So if my parabola looks like this and it has a negative, well, then it would just be heading down in the opposite direction because of that negative. And then, of course, when we have the h, yes, it says x minus h. H indicates a horizontal translation. But remember, we've also said that if it says x minus h, right, I'm basically, for this one, going to the right. And then if it says x plus h, well, then we're going left. Remember, we always think opposite with these. We always think opposite when it's inside the function. So that rule hasn't changed. And then finally, we have this k. And the k, when it's out here, the k indicates a vertical translation. Well, we talked about that too, where we said if it says plus k, I'm going up. If it says minus k, well, then we're heading down. It's not the first time we do this. We've done this with absolute values. We've done this with quadratics. Well, now we're going to do the exact same thing, but with cubic functions. So Best way to show you this is, of course, with some practice. So here it is. But again, let me see if we can make it fit there with everything we need, including this info we just learned. Okay, here it is. All right. Describe the transformation of f of x equals x to the third, represented by g of x is equal to x plus 5 to the third plus 2. So here's a couple things I noticed. My a value. Well, my a value is just a 1. Well, now I need my h and my k. Well, here's the h, but if it says x plus 5, then my h, I got to think opposite, so it's negative 5. And then, of course, I look at my k, and this one says plus 2. So then we're going plus 2. So then my point of inflection using these numbers are negative 5, because I was supposed to think opposite, and positive 2. And so the moves that are being made is this. Think about how you have to draw this point. To draw this point, I have to go to negative 5, positive 2. So it is a translation in this case of left 5 and up 2. Okay? It tells you there. The way you draw the point is how you describe the translation. Left 5 because it's negative 5, up 2 because it's positive. And the next question says, well, do you have a reflection across the x-axis? Well, my a-value is positive. If my a-value is positive, then no, we do not have a reflection going on. And then it asks for domain and range. So we're actually ready to draw it. If my a-value is 1, then the idea is I would just go up 1, 1 over. So I'm going to use this point. But because it's a cubic, the other one is down here. Remember, we're not drawing a line. That's what you got to steer clear from. Steer clear from drawing a line. And so here comes my graph. Remember, think of it this way. You're drawing half a parabola going up and half a parabola going down. Remember, they open up forever to the left and they open up forever to the right. That's how you can't draw them going straight up. They continue to go to the left forever and up forever. Well, in this case, right forever, up forever. This one is heading down forever, but also, of course, to the left. So that's why my domain, remember, this is a polynomial function. This thing is going to go to the left forever, go to the right forever. Then my domain is all real numbers. And the reason for that is this. It goes left forever, right forever. People always see it as, oh, but it goes up. It goes up, yeah, but it also goes to the right. If it just went straight up, it would have been right along this line. But left forever, right forever. There, because I can't make the other word fit. And then it comes to range. Well, range has to do with my y's, my domain where the x is. So let me ask you about my y's. See, when you look at my y's, does this graph go down forever? Well, absolutely, it heads down forever. It also goes up forever. So my range for a cubic function is also all real numbers. So it should be one of the easier questions to answer. And again, the reason it's all real numbers is that it goes up and down forever. That's the reason. But remember, they don't shoot straight down. It's going down and to the left. This one is going up and to the right. But there it is. There's my graph. Again, if you notice, I really just need this. I need my inflection point. I draw it. My a value is 1, so it's just 1 up, 1 over. So then I go down 1, 1 over. And then I draw my half a parabola, half a parabola. That's how we have to think of it. All right, here we go again. Let's try another one. All right, so I'm looking at this one. They said describe the transformation. It is a cubic. Okay, this one's a cubic, but look at your a value. Your a value is a -1. My b value says x minus 3. So if it says minus 3, my h is positive 3 because I got to think opposite. And of course, my k is -1. So -1. We only think opposite for this one when it's in a parentheses. So here's my inflection point. It's 3 and -1, just coming from here as well. So my translation, well, if I have to draw this point, 3, I would go to the right. -1 means I drop it 1. There's my point on the graph. So there's my translation talk. I'm going right 3, and I'm going down 1. Now, the question about reflection. Well, remember, my A value is negative. This is what affects the concept of reflection. So yes, there is definitely going to be a little bit of a flip. So remember, my original goes like this, right? We see it here. So if I flip it, it's going to go like this, just the opposite direction. This is what the flip looks like. So when I'm looking at this point, remember it says -1. So I go down 1 and over 1. So there's my first point. But because it's a cubic, we already know the other one should be right over here on this side. And so just like that, here's my graph. Remember, half a parabola going up, half a parabola going down, and there it is with the flip and all. Now remember, it doesn't shoot straight up. It's going up and left forever. It's also going down and to the right forever, which is why my domain is now very easy to answer. It is all real numbers because it does go to the left forever, and it does go to the right forever, and it goes up forever and down forever. So then my range is also all real numbers. Again, a very easy question to answer when it comes to this concept. It's not like parabolas where all of a sudden there's a vertex and it gets cut off. All right, so now that's our first attempt at graphing these. And again, notice it's really just the inflection point. And then if you notice, it's the 3 basic points. Now, because it got flipped, it's going this way. But earlier, look at that. It's always the same 3 points. After the inflection, my A was +1. I went 1 up, 1 over. Here, my A value is -1, so I went down 1, 1 over. And then because it's a cubic, we know we're going the opposite direction. All right, flip it over. Let's see what other types of questions are going to throw at us. So describe the transformation from this point to this point. All right, so a little bit different. They want to know, how did it go from here, f of x, to this one? Well, look, now we're going to go right into it. Let's talk about f of x first. So here is f of x. And right away, we don't think about it too much. I want to know my point of inflection. If it says x minus 2, then I'm going +2. It says +1, so +1. So I'm going to draw that point here, actually. 2, -1, 2 +1. And because it is a positive A, it's actually doing this. We don't really need all of that. But that right there is f of x. Just a small little picture of it. So there's f of x. Okay, well now let's look at g of x. So g of x, looking at this function, again, I look inside my parentheses, and it says x plus 5, so I'm going -5. And then -4, so -4. All right, I'm going to go draw that point over here. -5, -4 would be right here. And because my A value is also a 1, I know it's doing this. All right, so there's g of x right there. Let's give it some color. And all they're saying is this. And all they're asking is, so they just want me to see how to describe, they want me to describe the transformation from f of x to g of x. Well, all we have to do is just look at one point. So if we look at it carefully, we already see that for me to get from this point to this one, well, we have to go this way, about that many spaces right there. But then we also have to head down. So we're going this way, a little darker color there. And we also have to head down to get to that point. Well, all I have to do is put it into words. All I have to do is go left. Well, let's see how many spaces. 1, 2, 3, 4, 5, 6, 7. So left 7, and I also have to go down. So we can start writing that, and down 1, 2, 3, 4, 5 spaces for this one. So down 5. And there it is. They wanted me to describe, well, how do I go from here to here? Now, it can also be done just by looking at points, right? If I started off at 2, 1, and I'm going to end, so this is where I start, but then I end it, just want to show you there's another option, and then I end it at -5, -4, well then, the question becomes, how do I go from a 2 to a -5? Well, the only way to go from a 2 to a -5 is if I subtract 7 to get that -5. Well, that's why I'm going left 7. How do I go from a 1 to a -4? Well, if they're getting smaller, I'm subtracting. And chances are, there it is. 1 minus 5 would be a -4. These are the moves right here. These are the moves that have to take place. Left 7, down 5, for me to get from one point to the other. So you could do it with a little bit of arithmetic, trying to figure it out, or graph it. So you have two options to do that. All right, so we're going to pause for a moment. So we're going to pause the video so that you can do the U-try problems. You're going to try number 4 and number 5 on this page. So we're going to get started with that. And then if you notice, we still have a couple more problems on the back. But right now, I just need you to try the U-tries number 4 and number 5 and then check your answers. So let's pause the video. And we'll come back with the rest of the notes. All right, so at this point, you should have already checked your answers for number 4 and number 5 on the key. So I wanted to talk to you about these, and we're going to talk about it together for these problems. If you've tried them, great, check your answers. If you haven't, then just kind of go along with us here. A value is going to be a 1 for this problem. So another little review question. X plus 2, so that means we're going to go opposite, so -2. And then it says -3. Well, then it's still a -3. That's why my inflection point is -2, -3. Again, that's how quick number 4 and number 5 should have been done earlier. This one has a negative, so that's why I always want to talk to you about these first. If I draw this point -2, -3, remember you're going left 2, down 3. There's the point. So we go left 2, and then we go down 3. Now the question is there a reflection? Well, absolutely. Look at this thing. This is a -1. Almost forgot to write the negative earlier. So that does affect the reflection. So then, yes, there is a reflection. And by that, it means my graph better look like this. It should take that form. All right, so let's see. And we can already answer this one. Domain is all real numbers. I don't even need a picture anymore for this. If you understood the notes from earlier, my domain and range is always all real numbers for a cubic function. That's a great thing about polynomials. And so now here we go. Now remember, it's got to look like this one. I know normally we just choose these 2 points, but because it got flipped, then it becomes these 2 points that we look at. And just like before, here's my graph. We go with half a parabola going up and half a parabola going down. And there's my cubic function. Again, just watch out for those negatives, right? It's a flip, but it's always the classic 3 points. It's the same 3 points that we use for a line, for the most generic line, but now it's for a cubic. And then there's number 7. Now, when I'm looking at number 7, it seems very similar, right, to the last problem that we just did, but it's multiple choice this time. But again, I want to show you how we do this for the test. They said, which equation / transformation represents the graphs below? All right, well, first of all, look at this one. F of x hits 0, 0. It hits 1, 1. It hits -1, -1. This one is the parent. Anything that hits 0, 0, 1, 1, -1, -1, it's called the parent function. And that's why, if you look carefully, they all say the same thing. So that wasn't the question. All right, that's not the real issue. The question is about G. And so the question becomes, well, how do I go from F to G, okay? Now, once we are going from this point, we are trying to find another point on the graph, which would be this point right there. We always look for that inflection point there. And in the inflection point, we're going from f of x to g of x. So then all we have to do is just count spaces, everybody. So let's start doing that. Remember, if I'm going this way, I'm going 1, 2, 3, 4. Now, in this case, we went 5 left. So 5 left. We also go 1, 2. So we go 2 up, which means my inflection point is -5, +2. So here I go. I'm looking for an equation. They called it g of x is equal to x. Remember, we went left 5, so that's got to be a +2. Sorry, a +5 squared. Oh, why does it keep messing up? Power of 3 plus 5 power of 3. And then it's a +2. And so just like that, we have our answer. There's the g function. It's really all about a vertex. So you can do the counting if that helps. But if you find that vertex or inflection point is the real way of saying it here, that inflection point was -5, 2. That should have led to that right there instantly. Or you could do the counting. It's whatever helps, whatever works for you better. All right, last problem here, number 8. The cubic function f of x is equal to x minus 1 to the third plus 3. Now, here it's nice and ready for you. But if you get problems where they don't do this for you, well, do it yourself. F of x is this equation right here. So the inflection point x minus 1, then it's +1, +3. But then they said this. You started here. It has been translated 5 units to the left and 1 unit down to form g of x. All right, now, again, we can actually already come up with this if we wanted to. If the graph is here, let's use it. 1, 3, 1, 3. My a value was a 1, so it's going to be like this. There's f of x right there. But then think about what they said. They said you're going to go 5 to the left. So we're going 5 left. 1, 2, 3, 4, 5. And you're going to go 1 down, it says. So we're going to go 1 space down. So 1 space down. That right there is my brand new, it's my brand new inflection point for g of x. So the point of inflection would be -4, +2. And now this brings me to my equation of g of x. So there's g of x with all the changes they wanted me to make. All right, so here we go. It's heading up, it's positive, so all I'm going to do is go right into x. It says -4, so then I'm going +4 to the power of 3, of course. And then it says up 2, so then +2. And just like that, there's my equation. Now, again, what if I didn't have a graph? Well, just keep in mind, you could have done it like this. Here is my point of inflection. They said 5 to the left. Then that would take away a 5 from here. I go up 1. Well, up 1 would go with the y, so +1. And then look, those are the same numbers if I actually do the math there. But whatever move they're asking you to do, you can turn it into a little arithmetic to find out that the new coordinate, which we already have over here, but if we wanted to, we could just say, okay, well, this is -4. And 3 plus 1, or 3 minus 1. Sorry, it was down 1. Just caught it there. So because it's -1, then we would have had the 2. See? Same answer. So you either do it with a graph if you have it available. If not, you're going to talk about the moves mathematically speaking. If it says 1 down, and that was my mistake earlier, then it's a -1. All right, so with that said, you have the classwork for today, so make sure you start working on that. Double check your answers, drop it off. And of course, you got that quizzes as your homework, right? It's really not homework, it's your exit ticket. So Make sure you take your time on that one and get 100%. All right. Have a wonderful break, everybody. Enjoy your Thanksgiving. And, well, I'll see you in a week or so.